Hi, welcome to new video. In this video, we will discuss method of moments. What is the method? Method of moments. So now let us discuss what is method of moments. Method of moments is also a technique for estimating the parameters of a statistical model by equating sample moments to the corresponding theoretical moments of the distribution. It is one of the oldest and the simplest method of all the parameter estimation. We have already discussed about the maximum likelihood estimators and minimum chi-square method. So in the previous videos, you can see these methods also. Right now we are discussing about the method of moments. First method, this is the simplest and easiest method. Now, first, what are the sample movements? Sample movements are those movements like first the form of the movement of this is the sample movement. Kth sample movement look like this one 1 by n summation xi to the power k. Suppose that I want to find m1. M1 means the first moment. So for this 1 by n summation of xi, so this will be x bar. It means that mean. Similarly, if we will put here 2, so m2 will be there. So 1 by n summation of x is I square. So this will be sample variance plus, and this is not actually a moment, so this is a only the second sample movements. This is sample movement 1, this is a sample movement 2. So first one is m1, which is a sample mean, and second one which is sample m2, which is a sample variance plus sample mean equal whole square. Right now we are discussing the theoretical movements which are discussing here. It is uh, written by mu. So mu1 will be mean and mu2 will be variance plus mean square. These are the formulas you can learn about them, and the first formula is mu1, which is always mean, and the second one is the variance plus mean square, and the third one is estimation. Estimation is solve this system of equations where sample moments equal theoretical moments. So mk equal to mu k theta. So this is the, so in this one actually we are equating the two different moments, sample moments and the theoretical moments. Now let us discuss about the example. First we have some samples are 1 2 3 4 5 and want to estimate the parameters of the normal distribution. So in this one, first we will discuss about sample moments. We will find by the sample moments, and sample moments are m1 equal to 1 plus 2 plus 3, which will be 3 after calculating. And then again m2 we will calculate by the summation of xi square upon n. So this will be 11. Now theoretical moment, we know that mu1 and mu2. So mu1 is mu means that mean, and this is sigma square and the mu square. Now we know that mu is 3, so we'll write here 3, and sigma square, which we have not found, so we'll found this, and we know the mu2 value. Mu2 value is 11 and sigma square, and we know that mu also, so this will be 3. So sigma square will be 11 minus 3 means that, sorry, this one will be 3 square. So it means that 11 minus 9 means 4, so summation will be 2. So our sample, we can say our uh, I think we can say we can take this value, and this variance is 4 and the mean is equal to 3. So in the property, when we are talking about the properties, so these are the simple matlab ki easy to understand and implement. Second one is consistent. So every method is consistent because when we increase the size, so it will automatically will be better. And the third one is asymptotic normality. This property is also depends on the number of सैंपल्स. सो सैंपल का साइज जितना बढ़ाते जाएंगे उतना ज़्यादा ये प्रॉपर्टी अच्छा होता जाएगा. एंड एफिशिएंसी भी इसी पर ही डिपेंड करती है कि जितना ज़्यादा अच्छा है एफिशिएंट, यानी कि जितना कम वेरिएंस होगा उतना ज़्यादा ये एफिशिएंट देगा. और वेरिएंस कम होना जो है वो सैंपल पर डिपेंड करता है. जितना सैंपल साइज बड़ा होगा उतना वेरिएंस कम होता जाएगा, और वेरिएंस कम होगा तो इट विल बी एफिशिएंट एस्टिमेटर. तो यहाँ पे हमने समझा व्हाट इज द मेथड ऑफ मूवमेंट्स. मेथड ऑफ मूवमेंट्स के बारे में जाना. अगर आप और भी जानकारी जानना चाहते हैं तो हमसे बता सकते हैं वीडियो में. और अब हम नेक्स्ट वीडियो में पढ़ेंगे लीस्ट स्क्वायर्स के बारे में. थैंक यू.